5.2. Okay, so 5.2a. This lesson we are going to start factoring quadratic expressions. Now, this is probably going to be one of the most important lessons of the year because we will use factoring throughout the whole year. Now, when we factor, okay, there's three things I want us to think about initially. Okay, the first thing you need to think about is to look for what we call a greatest common factor, or a GCF. Okay, greatest common factor. Okay, so whenever I say factor this quadratic, that is the first thing that should go through your head. The second thing, once we take care of the greatest common factor, if there is one, the second thing we're going to worry about is to see if there is a special case. Okay, for right now, all we're going to worry about is one special case, and this special case is called the difference of squares. Okay, so let's break that down. Difference, this is meaning subtracting. Okay, so we're subtracting perfect squares. Okay, and we'll talk about perfect squares once we get to some of those examples. And then finally, the third thing is just a matter if it's a trinomial. Okay, trinomial, meaning it just has three terms in the expression. Okay, and from there, you know, it's really going to be just guess and check. Okay, the more we do this, the better you're going to get at it. Okay, so it's going to be very important that you do all of the homework for this lesson. So the first example, okay, factor the quadratic expression a 14x squared plus 2x minus 12. Again, the first thing we always need to think about when doing this is to take out the greatest common factor. Okay, what number goes into all those coefficients, and if there's a common variable as well between all three terms. Okay, so in this first case, 2 goes into the 14, 2, and 12. So 2 times 7x squared will give us that 14x squared plus x minus 6. Okay, then from there we could possibly factor even further. Okay, that is just the first step we always need to look at when we're doing this. So 2, okay, and then we're going to factor it. Okay, break it into two binomials that I can multiply to get that 7x squared plus x minus 6. Now, the first terms in each binomial is going to multiply to get that 7x squared. Now, the only way to multiply and get 7 is by 7 times 1. Okay, so those first terms are going to be 7x and x. Those are what are going to multiply and get that 7x squared. Then the next thing I'm going to look at is the signs. Okay, since this is a negative here, that means the signs in the two binomials here and here have to be opposite of each other. So one has to be negative, one has to be positive. Now, I'm not sure which one's which yet, but that's why we're just going to guess and check. So we're just going to say plus minus here. Now, for these next terms here, those have to multiply and get 6. Okay, so the options there are 1 and 6 or 2 and 3. Okay, so let's just start with that 1 and 6. 1, 6. And then from there, we're going to check to see if it is correct. Now, I know when I multiply, I'm going to get that 7x squared. When I multiply these two things, I will get that 7x squared. I know when I multiply these two, I get that negative 6. It's just a matter of that middle term now. Okay, so the way we're going to check for that is we're going to, basically what we've done the F and the L of FOIL. Okay, so we need to do the O and the I, the outside and the inside. So the outside and the inside, 7x times 6, okay, that's going to give us 42x, negative 42x, and x. Okay, when you combine these two things, that should combine to get the middle term there. So in this case, it is not working. So we need to possibly look at changing. Okay, so we initially started with that 6 in this binomial. So let's maybe switch that around. Okay, so that gave me 42, and that's going to give me way off of what I need. Now if I check my outside and inside, now I got negative 7x and positive 6x. When I combine those two things, that gets me negative x. I need positive x. So if that's the case, the only thing we are left to do is we need to change the signs. Okay, now it's positive and negative. Now we have finally fully factored our quadratic. Okay, so again, the more you do this, the better you're going to be able to see that combination of numbers and variables, the better. Okay, so next one, again, greatest common factor. Greatest common factor of 3v squared and 18v. Okay, 3 goes into both 3 and 18, so I'm going to factor out a 3. And then also, both terms have a v. So 3v times v minus 6. Okay, so again, if we were to distribute that 3v, we'd get that 3v squared minus 18v. All right, so up to this point, you guys have you've just distributed that and multiplied it out. We're going the opposite way. We're going into its factored form. Now, since there's no more squared terms or anything, that is all we can go for our factoring. So, C, again, looking for that greatest common factor. I see that 3 is the greatest common factor. Okay, x squared, x, no x. Okay, so x is not a common factor. But when I factor out that 3, I'm going to get 4x squared plus x plus 1. Okay, so now let's check to see if it factors further. So these first options, now we have it's either 4x and x or 2x and 2x. So let's go ahead, let's try 2x and 2x. Okay, since both signs are positive here, both of these will be positive when we factor it. And the only option is to do 1 and 1. So checking to see if it is factored properly, that's going to be 2x. 2x, okay, combined, that's 4x. That does not equal that x. So the other option we had was to do 4x and x. Now that's going to give us x and 4x. And again, combining those two things, that's 5x, which does not give us that x that we need. So if that's the case, we've ran out of options. It does not factor further beyond that 3 times 4x squared plus x plus 1. Okay. So the next one, greatest common factor again. I see that 4 is. Okay, so 4 times u squared minus 9. Okay, so now that middle term is missing. So let's just try something here. Okay, so if I'm going to break it up into two binomials here, it's going to have to be u times u. Okay, so because when I multiply that, that's going to give me the u squared. Now my next option is for here and here. Okay, it's either 1 and 9 and 3 and 3. So I'm going to just try 3 and 3. And then since this sign is negative, that means these have to be opposite. Okay, so if we check our outside and inside, okay, negative 3u and 3u. Combining those, that gives me the 0u that I need. Okay, now this is our special case. Okay, this is the difference of squares. Okay, so u squared minus 9. U squared is a perfect square, and 9 is a perfect square. Okay, so when we're looking at this, okay, I'm going to look for perfect squares. A lot of times when you only have two terms, this is when it's going to happen. Okay, so when I'm looking at variables, for perfect squares of variables, okay, so like x squared is a perfect square. X to the 4th, x to the 6th, x to the 8th, x to the 9th, no, not 9th, 10th, x to the 12th. Okay, what you're noticing, it's a multiple of 2. It's a perfect square. Because I could write x to the 4th as x squared squared. I can write x to the 6th as x cubed squared. X to the 4th squared. I can have a base that is squared to get that perfect square. Now, when we're looking at just numbers, okay, like 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared 25, and I can go on forever and ever with those perfect squares. We're looking for those specific type of things when we're looking for the special cases. So again, we're looking greatest common factor, and then we're looking for these special cases. So we are looking for these perfect squares. So in these cases, like x squared minus 16, x squared is a perfect square. 16 is a perfect square. So then we're thinking, what am I squaring to get that? Okay, I'm squaring x to get x squared, and I'm squaring 4 to get 16. Okay, if I go over here, okay, what am I squaring to get those two values? I'm, again, squaring x. Here I'm squaring 5. If we go to the next one, what am I squaring? Y. What am I squaring to get 49? 7 squared is 49. Next one. Okay, x squared. 3 squared is 9. So let's go through and let's finish those top ones. So now I'm looking at these specific things. What value did I, or what did I square to get that? So if we notice that it's a difference of squares. Again, we're looking for that it's subtracting as well. Difference of squares. We're subtracting two perfect squares. We're going to take that first part, which was x. Okay. We're going to do opposite signs. And then the second part, that was squared. Okay, so if you want to double check, outside, inside, that's going to give you negative 4x and 4x to give us that 0x that we need. Okay, and the first FOIL, x squared, and then our last, that minus 16. So the big part about this is to just basically notice the perfect squares. And once you do that, it's going to be pretty easy. Okay, because then it's x plus 5, x minus 5. If we go to the next one, it's y and 7, so y plus 7, y minus 7. Okay, hopefully you are seeing the pattern here. Okay, so here, x plus 3, x minus 3. Now these next ones are a little more difficult, still the same idea though. So, like when I go to 9x squared minus 25y squared, okay, what am I squaring to get 9x squared? 3x. Okay, 3 squared is 9, x squared is x squared. What am I squaring to get 25y squared? 5y. 5 squared, y squared. So when I actually factor this now, first term goes first, second term goes second, and then opposite signs. So the next one, what am I squaring to get 121 x squared? Okay, 11x. This is going to be 4 squared. So then 11x, when I go into my factored form, 11x plus minus 4. So for the next one, what am I squaring to get 4x squared? 2x. I'm squaring 3 to get there. So 2x plus 3 minus 3. And then finally, for the last one, I'm squaring 2x to get 4x squared, and I'm squaring 6y to get 6y squared. So 2x will go in the first plus minus, and then 6y from there. Okay, so those were our difference of squares. Hopefully you saw the pattern there. The big thing there is to make sure you can recognize the pattern. Look for those perfect squares, make sure they're subtracting. When it's a case where it's adding, okay, in our terms, I'm not going to teach you. It is factorable, but we're not going to worry about factoring them, because if you were to factor these, you'd still look at these squares. Okay, so like this one's x, 4, but in these cases, x plus 4i, x minus 4i, you don't have to worry about this. Okay, this is a sum of squares. Okay, you don't need to worry about factoring those. Just worry about the difference of squares. So when it comes to it, you can leave it at that. As soon as you see those are perfect squares and it's adding, leave it there. Okay. All right, so factoring trinomial of the form x squared plus bx plus c. looking at that first one, again, we're going to break it up into two binomials. First, look to see if there is a a greatest common factor. In this case, there is not. Okay, so x and x to get that x squared. Okay, we have a minus and a minus, so plus and a minus. Okay, because when I multiply these two values here, it needs to be negative. Now I'm thinking, how can I multiply and get 48? First one that comes to my mind is 8 and 6. Okay, because then I think 8 and 6, if I take the difference of those, that's going to give me that 2. It's just a matter of which one needs to be positive and which one needs to be negative. So let's just go ahead and try 8, 6. Do your outside, inside. That's going to give me negative 6x, positive 8x. That combining those will give me the positive 2. So that tells me I need to flip-flop my signs. That, when we combine the outside and inside there, will give me that negative 2x. Okay, so for the next one, no greatest common factor. Okay, to multiply and get x squared, it's going to be x and x. And I see that this sign right here is positive, but this one is negative. Okay, that's the indicator that both signs in here will be negative. And the way to multiply and get 9 is either 1 and 9 or 3 and 3. Majority of the time, it's not going to be that 1 and the number itself. It's usually somewhere in the middle. Not always, typically though. So I'm going to go with the 3 and 3. And I get negative 3x, which combines to give me that negative 6x that I need. Okay, so that is factored form there. Okay, next one. I don't see a greatest common factor. When you see just x squared, there's not going to be a greatest common factor. I mean, their common factor could be 1, but if I factor out a 1, it's not going to change anything. So we got x and x. I see a plus and a plus. So that means in my factored form, that will be plus and plus. Ways to multiply and get 16. 1 and 16, 2 and 8, 4 and 4. Okay, but then you got to remember, we got to combine those two values to get 8. So I notice that 4 and 4 will help me get to that. Okay, checking outside, inside, 4x and 4x combines for that 8x. So the next one, again, just x squared, so let's not worry about, the greatest common factor in this case. It helped to be on writing. Okay, we got a negative and a positive here, so they have to be opposite signs. Multiple ways to multiply and get 2. 2 times 1, and that's the only option. 2, 1. Okay, negative 2x, x. Even if I flip-flopped those, okay, that's going to be 2x and negative x. There's no way I'm going to get that positive 6x through my middle terms. So in this case, this one is not factorable. Okay, we went through all the possibilities. You can only use x and x on those first terms. You can only use 2 and 1. Okay, those combinations will never get us to that plus 6x that we need. All right, so next one. Don't get scared because there's x and y. Okay, it's still follow that same thing. Is there greatest common factor? In this case, no, we don't have to worry about that because it's just x squared. So then let's break it down. How am I going to multiply and get x squared? The only option is x and x. Okay, my signs, a negative and a negative. So we're going to have opposite signs. And then I got to think, how can I multiply and get 36y squared? Okay, first thing that typically comes to my mind is 6 and 6. Okay, but then when I combine the outside and inside, that's going to give me 0xy, whatever it is. So that's not going to work. So we got to think of another way. So the next thing that comes to my mind is 9 and 4. Okay, so let's say 9, but then we also have that y squared, so 9y, 4y. Okay, now when we check our outside, inside, that's negative 4xy, 9xy, which combining those gives me a positive 5xy. I'm looking for negative 5xy. So if that's the case, all we need to worry about is to flip-flop our signs. And that would be the factored form. All right. Now, once that a value of that quadratic gets away from 1, it gets a little more difficult, just because there's more combinations that can happen. So like in this first one, still look for that greatest common factor. This case, it is not there. Okay, so we're going to break it up into our 2 binomials. Now we got to think, okay, how can I multiply and get 4y squared? I can either use 4y and y or 2y and 2y. I'm always going to attempt the middle, okay? Because again, 1 and 4 or 2 and 2. I'm going to try this first, okay? The signs in their factored form do not change, okay? They are negative and negative, so we have to have opposite in here. And the only way to get 3 is 3 and 1, okay? So you can go ahead and you can just plug 3 and 1 in there and then check. Okay, so this is going to give us negative 2y and 6y. So that's going to give us positive 4y. I need negative 4y, so I'm going to flip these signs in our factored form. Okay, so now it's negative 6y and positive 2y to give us that negative 4y we need. The more you do it, the faster you're going to see that proper combination there. All right, so the next one. Okay, no greatest common factor. Ways to multiply and get 10x squared, or 1 and 10, or 2 and 5. Okay, I'm probably going to go away from the 1 and 10 right away. I'm just going to use that 2 and 5. So let's go 2x, 5x. And then our last, okay, this part has to multiply and get 1. So it has to be 1 and 1. That's the only way to multiply and get 1. And then I'm looking at my signs. They have to be opposite of each other because both are negative. Now I need to get negative 3x. Okay, so this is where the, more practice is going to help. I need to get negative 3x. So when I multiply, I want to get that 5 to be negative and the 2 to be positive. Because now when I do my outside and inside, positive 2x, negative 5x, which combines to give me my negative 3x when I combine them. Okay, so last two. No greatest common factor. Only way to get 2x squared is 2x and x. Has to be positive and positive. The only option for the last terms are 1 and 1. So we literally have one possibility here. And when we check it here with our outside and inside, we don't combine to get that 7x. So this is a case where it is not factorable. Okay, we went through all the options. There was only one option. We could not get it to be the original trinomial. So in that case, it's not factorable. Okay, the last one then. So greatest common factor. There is no greatest common factor. In this case, my options to multiply and get 9x squared are 1 and 9 or 3 and 3. Again, I'm always going to go with this route first. 3x, 3x. Okay, since this sign is positive and that one is negative, the only option I have is negative and negative. And if we think, okay, ways to multiply and get 4 are 1 and 4 or 2 and 2. I'm always going to go with that 2 and 2 first and then check to see where we're at. Okay, so that's going to be negative 6x for our outside and inside, which combines to give us that negative 12x. Okay. Now, way to check your answers, okay? Foil out your factored form. 3x minus 2, 3x minus 2, foiling it out. Okay, first one's going to be 9x squared minus 6x, and then the last plus 4. Okay, again, we did this part with the outside and inside. We should, every single time when we write it in factored form, we should get this correct because we made it so it writes out, like we picked 3 and 3x, 3x and 3x. For sure, no, that's going to get 9x squared. We picked 2 and 2, so we know that should be 4. It's always just a matter of checking those outside and inside of FOIL to make sure we had factored properly. All right. Factoring. Okay, again, this is probably the most important thing to get out of Algebra 2. Okay, so I want you guys to do all of the homework, every single homework problem. Okay, so 5.2, 260, 23 through 63 odds. Make sure to go through and factor every single one of those. Okay, if you have questions, this is the lesson to for sure ask them. Okay, so go ahead, get the homework done, and have a good day.